Hey everyone, I just wanted to go over some basic factoring techniques in case you needed a refresher prior to attempting these problems. All right, so the first one I'm going to start with is just a basic, this is a binomial, and we call this the GCF, which basically I just want you to remember that's your first rule when it comes to any kind of factoring. I want you to think about what is the greatest common factor. So if you look at 7a squared and 49a, you will recognize that there's both not only a 7 involved in both of them, but they also have an a in common. So the first thing I'm going to do, my first set of factoring, is to go ahead and factor out a GCF. So I'm going to factor out a 7a from this. And so I'm left over with a plus 7. Now at this stage, once you factored with GCF, then you would look to see if you can factor it again. And obviously in this one we can't. And so that's how we kind of know that that particular factoring problem is done, or it's factored completely. All right, next thing I'm going to show you is difference of two squares, commonly called dots. So difference of two squares is also dealt with a binomial. So that means this is a term, this is a term. There's only two terms in each of those two examples. And what you will notice is it says difference of two squares because there's a subtraction sign here. So this doesn't work if this is a plus sign. So anyway, what happens is first you look for a GCF. And so in my first example, x squared minus 64, there isn't a GCF between the two of them. Next, if you notice that this term right here, so this x squared, and then also this 64, if they're both perfect squares, we can follow the pattern for a difference of two squares. And how the pattern works is basically you kind of set up two parentheses. You take the square root of whatever's in this first term. So the square root of x squared is x. You make one parenthesis positive, one negative, doesn't matter which order. And then you take the square root of this number. So the square root of 64 is 8. So this factors into x plus 8, x minus 8. And that's what we call a difference of two squares. On the next example, I'm going to show you that first you always want to look for, it doesn't look like a difference of two squares because 2 is not obviously a perfect square. But remember your first rule of factoring. Factor out a common like GCF. And if you do that, so if you factor out that 2, now the 2's out here, but now you might notice this x squared and this 100 are both perfect squares. So the 2 kind of comes along for the ride, but now you can factor this x squared minus 100 into x plus 10 and x minus 10. All right, next I'm going to show you how to factor a trinomial. When your a term is not equal to 1, that means the number in front of x squared. So in other words, when it's a is equal to 1, you won't see any other number there. We use, traditionally when we do Algebra 2, with Algebra 2 students, we call this the guess and check. We kind of want you to be able to factor this without a whole lot of gimmicks or drawing pictures or anything like that. So the general technique is if you have an x squared or whatever variable squared is here, you're looking at what two values multiply together to give you that first term. So like x times x gives me x squared. Next, what you're going to look for is numbers that multiply together to give me 12. And then they have to multiply together to give me negative 12, but then add to the middle term. So you want them to multiply to this last term, but add to the middle term. So think of numbers that multiply together to give me negative 12. So we got like 1 and 12, so like negative 1 or negative 12. And then we've got 2 and 6 and 3 and 4. So in this case, in order for me to get 1 as a middle term, if I made this negative, so a 3 negative and the 4 positive, negative 3 and positive 4 multiply to negative 12, but add to positive 1. And that's how I know what goes into those parentheses. We just call this the guess and check method. Eventually, as you do more of these, which hopefully you're comfortable with this, or if you're not, this is definitely something I would work on. We do a lot of factoring in Algebra 2. All right, last but not least is another type of trinomial. This is called, we use something called the AC method, which basically this just means is we have a trinomial where this time there is a number in front of x squared. and it's not a 1 this time. So there's a couple ways you can do this. You can always use the guess and check method like I just did, or you can kind of go through this method until you get more comfortable with factoring and using what we call the AC method. We call the AC method because this is your A term, this is your C term. So what I first want you to do is multiply those two numbers together. So 6 times -5 is -30. And then what I do is I list all of the factors of -30. I kind of just list factors of 30 and then kind of go from there with the negative signs. I kind of worry about that in a minute. So 1 and 30, 2 and 15, 3 and 10, 4 does not work, 5 and 6, and I think that's it. So we need a set of factors that's going to equal this middle term if I add them together. So kind of like the guess and check method, this time you multiplied A and C together, but now you want these two numbers to multiply together to give me -30. So they multiply to -30, but they have to add to that middle term. So the only numbers that would actually work here would be well, it could be 3 and 10, or it could be 2 and 15, right? Because you could kind of make this work. So let's see if we could play around with the signs here. If I had 2 and 15, in order to get +13, I would need -2 and +15. In order for 3 and 10 to give me +13, I need to be +3 and +10. So now you're probably asking, well, how can I have two sets of numbers? And the answer is you can't, which is why this one doesn't work. And the reason why it doesn't work is because +3 and +10 does not multiply to -30. The only ones that multiply to -30 and add to +13 are -2 and +15. All right, so now that you know these are your factors, what you do is you kind of replace your first term, so just rewrite 6x squared. You're going to plug in the -2, put an x after it, and you're going to plug in the +15, put an x after it. So basically what you're doing is you're rewriting 13x as -2 plus 15x. And then you keep the last term, which in this case is -5. All right, now we do something called factor by grouping. You might be familiar with this. You probably learned this in Algebra 1. So factor by grouping basically means there's 4 terms. We look at, I kind of cut it in half like this just so I can see it. We factor out a GCF from the first 2 terms. So if we do that, I'm going to factor out a 2x. So I get 2x, and then I get 3x minus 1. Whatever this sign is here, you carry it down, and then you factor out a GCF from this term. Notice how this parenthesis here is the same as this parenthesis. That has to happen in order for us to be factoring correctly. If it doesn't give you the same exact value, you either A, did something wrong, or it's not factorable. All right, so now that we have this, we've kind of done with the factoring, what you'll notice is in this part of the value before the plus sign and this part of the value after the plus sign, they both have a 3x minus 1 in common, and then the leftover is 2x and plus 5. And so this is the factored form of that equation. So the AC method, while it does seem like a lot of steps, the more you do it, the better you get at it and the quicker it goes. What I like about the AC method is, although I don't use it very often because, well, I can do a lot of factoring, it does provide you with a fail-proof plan. Like, in other words, if you follow these steps, it will always work. Whereas the guess and check is obviously guessing and checking. So this is a nice option if you just kind of like to follow a rule and be able to always have kind of a backup plan. All right, good luck. Thanks.